Welcome to Intermediate Algebra, Unit 7, Lesson 1. This is the video 1 of 2 videos dealing with simplifying rational expressions, multiplying and dividing rational expressions. So our lesson objective in this part is to be able to simplify rational expressions by factoring and reducing like factors. So what is a rational expression? Is an expression that's in the form of a fraction. Now that word puts fear into people's hearts. So I'm hoping we'll make this a little less frightening if it is to, and if you're good with fractions with numbers, this is going to make sense and it shouldn't be a big deal. The difference here is, now that we're in algebra, we have a polynomial divided by another polynomial, and that the polynomial can have as few as one term or more terms. The top is still called the numerator, just like with numbers, and the bottom is still called the denominator. So when we talk about simplify, what we really mean is reduce the fraction. With numbers, we call it reducing many times. So we want to reduce a numeric fraction to lowest terms. I'm going to use the example of 24/32. What you do is you look for the greatest common factor of the top and the bottom. And the truth is, you could factor these out. 24 and prime factor it and prime factor 32 and find factors that match. But I see in 24 that the top can be factored as 8 times 3, while the bottom can be factored as 8 times 4. So I factor it that way. And when we multiply fractions together, we multiply top times top over bottom times bottom. So I can kind of do that backwards. I can take this single numerator, single denominator, because everything's multiplied. Can't do this with addition or subtraction. But because it's multiplied, I can break it up into 8 divided by 8 times 3 divided by 4. Because when you multiply fractions, if you were asked to multiply this, you do 8 times 3 over 8 times 4. So I would hope you would recognize before you multiply, though, that 8 divided by 8 simplifies. Any number divided by itself simplifies to a 1. So once I break this problem up into a like factor over itself, and it times multiplied by what's left, that like factor divided by itself becomes a 1. And all I have, 1 times 3/4, any number multiplied by 1, 1 is the multiplication identity unit. Any number multiplied by 1 is the number. So a 1 times a 3/4 is 3/4. So you're looking for common factors and using the fact that a number divided by itself is 1 to reduce your fraction. Now you may have done that many times. You may have not entirely understood what you were doing. Your calculators all do that for you now with numbers, but it won't do it with letters. So here's an example with letters. Simplify. Now notice there's letters on the top and not on the bottom. This is still a rational expression. This is a polynomial with only a constant term on the bottom. So we're asked to simplify. 4a plus 8 is on the top and 2 is on the bottom. I need to caution you here. You can only simplify if you are simplifying something from the top that's multiplied by the rest over something from the bottom. You cannot do just 4 divided by 2 is 2 and get 2a plus 8. That will not be correct, and you can't just do the 8 divided by 2. Now you could do 4 divided by 2, 8 divided by 2, but nobody ever remembers to do the whole thing. They always do one term and stop. So I'm going to show you what you want to do is you want to factor the top. And you could factor this as a 4 times a plus 2, but you see I have a 2 on the bottom. See if you have a 2 that comes out on the top. That's your clue. Sometimes the bottom will give you a clue as to how to factor the top, or the other way around. The bottom is simpler here, so let's see if we can take a 2 out of the top. And we can, because 4a has 2 as one of its factors, and 8 has 2 as one of its factors. So if I rewrite the top as things multiplied by 2, I get that. I undistribute that common factor. I get 2 times 2a plus 4. And here I see, now I wrote 2 times 1 there. You don't have to do that. Just understand there's always a 1 implied in multiplication. We don't generally write it. The reason I wrote it, though, is because of what happens here. When you do 2 divided by 2, you get a 1. and that leaves a 1 on the bottom. So a 1 on the top and a 1 on the bottom. So 2 divided by 2 is 1. So I'm simply left with 2a plus 1 over 1, and there's a mistake here. I'm very sorry. That answer should be 2a plus 1, not 2a plus 4. So please correct that if you're taking notes. That should be 2a plus 1. Okay, you can see that. Oh, no, sorry. Here's the mistake. That was 2a plus 4. I typed the 1 there. It should be 2a plus 4. The answer is correct. This in-between step has a plus 1 that needs to be fixed. So that's a mistake. I wrote my work out funny. Sorry about that. All right, now let's look at another example. This one is a little bit trickier because the top and the bottom, neither of them are single terms. But you go about the process the same. I look at the top, and the way I factor the top is I first look for any common factor. 3 goes into 9, 3 goes into 6, 3 goes into 3. Now I have an x, then an x, y, and the y, so no letters occur in each term. The y is missing from this, the x is missing from this. So I factor out the 3 first, that's right here. And what the step that isn't written is that will leave me with a 3x squared plus 2xy minus y squared. That will factor to x plus y times 3x minus y. So I had a 3x squared plus 2xy minus y squared after I move the 3, and it factors to these two factors. Now I look at the bottom. So this is a big factoring problem, really. You have to factor the top, you have to factor the bottom, and then see what you get. I can take a 12 out of each term, so I get 12, and that'll leave me with x squared minus y squared. The difference of two squares factors as x plus y times x minus y. Now I see I have a 3 over 12, and some of you learn to do this as, 3 goes into 3 once, so I'll write a 1 up there. 3 goes into 12 4 times, so I'll write a 4 down there. You can do it that way. But if you didn't understand what you were doing then, what you were really doing is you're looking for things that are common. I have an x plus y, I have an x plus y, so I put those in my factor out in front. So 12 has 3 as a factor, so I'm going to break that 12 up into 3 times 4. Now what I've done is I've got all the common factors on this side of this. I've created that multiplication problem by doing it backwards. So I get 3 times x plus y over 3 times x plus y. Something divided by itself is a 1. Or you can say 3 over 3 is 1. X plus y over x plus y is a 1. So I don't typically write the 1. What I'm left with is this, 3x minus y divided by 4 times the quantity x minus y. So here's a guided example. Again, and those were kind of guided examples too. We're going to look at simplifying 6x squared plus 4x divided by 2x squared plus 4x. And notice you cannot just say 4x over 4x is 1 and get 6x squared plus 1 over 2x squared plus 1. It will not be the same. It will not be equivalent. If you put numbers in for x and you did 6x squared plus 4x over 2x squared plus 4x, you get a different value than if you did 6x squared plus 1 over 2x squared plus 1. You can only reduce things that are multiplied. If I look to cross out this top 4x, I stop at an addition, so I can't do that. So let's see. You think about that for a minute, see what you think you would do, and we'll move on. Alright, so the top, I'm going to factor the top. I see I have a common factor of 2x. 2x times 3, and that leaves me 3x plus 2 when I undistribute the 2x. The bottom also has a common factor of 2x, and that leaves, and now once I factor the top, you could use this as a clue as how you might factor the bottom if you were stuck. See if 2x is a factor. See if 3x plus 2 is a factor. Here the 2x is a factor, so I get 2x times x plus 2. Again, the 2x over the 2x. I'm thinking most of you are not going to write this step. You're going to go right here and reduce those and replace them with a 1. But I'm just showing you why that works. So that leaves you 2x over 2x is a 1, so that's the same as saying 3x plus 2 divided by x plus 2. Alright, now here's one for you to try. I want you to stop the video in a moment and try factoring and reducing this problem. Alright, Hopefully you stopped the video. If you didn't, stop it now and do the problem. Alright, we're back, and I'm going to show you the answer. So I had to factor the y squared plus 3y plus 2. Gives me a y plus 1 times a y plus 2. So you can see if you're behind in the factoring unit, this is going to hurt you badly here. We need to make sure we regroup on that. You get help. You go to the tutoring lab. Email me. I'll give you ideas for more practice if that's what you need. But I have to be able to factor the top, and the bottom is the difference of two squares, y plus 1 times y minus 1. And what I see is I have a y plus 1 here and a y plus 1 here. Now it would not have made a difference if I wrote y plus 2 and then y plus 1, because order doesn't matter in the multiplication, so the top could have been written in the other order. I could still reduce the y plus 1 with the y plus 1, and that leaves me with y plus 2 divided by y minus 1. Okay, so that's it for our instructional piece of this. And what I want you to do is try some of the practice problems. There's some more in the guided notes. Hopefully I've posted the answers to those. And there's certainly homework that goes with this. And don't forget to watch part 2 of the video, but you might want to try a couple of these first. All right, thank you.